What about now? Oh, hello, this time it's serious. So, um, I have a confession to make. In somewhere 2006, I have done something that I regret, something that I'm not proud of, and I would prefer to keep it as a secret. However, being here today on this stage with you all, I honestly believe that I should reveal it. In something in 2006 that I can only justify with lack of experience, I thought it would be a good idea to learn Java. However, I think I was wrong. So many years later, I'm a C# developer, and I'm speaking at a festival to another C# developers about a technology written in Java. So, but I'm doing it because I honestly believe that you are here because you have been hearing about Kafka. You have seen that huge tech companies use Kafka. And you are curious about it. You want to understand how Kafka can be useful to you as a developer, as someone that needs to build an event-driven application. And likely you couldn't find that talk for you. My name is Guilherme Ferreira. I know that Guilherme is really hard to pronounce. Okay, I'm Portuguese, so feel free to call me Gui. And likely as you, I had to learn Kafka because I joined the company with a huge event-driven architecture. And so I had to learn it. And they use Kafka a lot. And during the process, I'd done what I usually do. I went online and looked for talks. And most of the talks that I could find, I couldn't relate to them. I couldn't find a good example of what type of concerns do I need to have by building an event-driven architecture with Kafka. Most of the things that I could find were either a small example just sending an hello message, or I would start with the basics without knowing anything about Kafka, and by the end, I was talking about Kafka Connect and Kafka Streams that are things that even nowadays I don't need, okay? So I wanted to build that talk. I wanted to build a talk to answer those questions. A talk that was most about code, that was most about stories, most about challenges that you face when you are building a real example, a real world scenario. So I have built some applications, a system that I have that is currently in production. And I want to show you the code of that application that relates to Kafka, the challenges that I faced. I want to show you the diagrams that I had to think, the problems that I had to solve. And during the process, I will teach you the basics of Kafka. So I will not use slides. We'll see a lot of code. We'll see diagrams. And I hope you feel comfortable with that. Some housekeeping before. If anyone here has experience with Kafka, likely this session is not for you. The goal is, if you are getting into Kafka, this session is your starting point. So if you want to leave to another room, I will not take that personally, okay? So feel free to do it. And I told you that this talk is based on a real world example. And what example is that? In last year, August, somewhere in August, I published my first YouTube video. And it starts with a personal challenge. I'm not a native English speaker, as you already noticed for sure. And I had to find a way to keep practicing it. If you are not a native speaker, you know the challenge that it is to speak two languages or even more. So I decided to start with YouTube because of that. And eventually, I liked the process. There's even one thing that I really like on my YouTube channel that I always show to everyone, and I want to show to you as well. If you go to youtube.com and you search for Gui Ferreira, you will not only see me doing some face expressions that I didn't think that I was capable of before starting this thing, but a YouTuber should do it, right? And also, sometimes you will see that I'm sharing the stage with this amazing Brazilian singer. It's not me, I promise. And he has beautiful music. Let me try to place and one. Anyone here knows Portuguese? You know? So you know that this is a music about making love, right? So love songs, the type of thing that you don't get when you search for Nick Chapsas online. And by the way, this festival is all about tech and music, and I just gave you both. So I deserve a green card on the way out, okay? We agree on that? Perfect. So you might not notice, let me see if you can read. I have 5.6K of subscribers, right? So this is not a lot, obviously, and it brings an extra challenge. That is, how does this thing will pay the bills? The question that one day, being on the couch, my wife asked me, how does this thing will eventually pay the bills? So being a developer, I answer in the best way that I know. I grabbed my laptop, I opened a Google spreadsheet, and I told her, it depends. She didn't find that funny. Okay, she's not a consultant or knows anything about software development, so I had to find another answer. And the answer is on that circle that you can see right there. Most content creators use Patreon to earn some money to justify the time that they invest on this type of thing. So I decided to do the same thing, but I wanted to do it in a way that makes sense nowadays. That is not an experience of the past. That is something that makes sense in 2023. How? By giving them access to my GitHub organization. I don't want to give the experience to my patrons that they download a zip file, unzip it, and then they have the source code from my videos. But also, I had a lot of ideas of things that I could give them, okay? Other benefits. But I had to start somewhere, and usually you start with your MVP, and this was my MVP. So I had a challenge to start. You can see there that Patreon has an email. Okay, I have the email of the person that is sponsoring me, but also you can see that on the other side, GitHub will ask me for a username. Okay, if I want to give you access, I need your GitHub username. So I have a challenge here that I have to solve. I have to find a way to map from one to the other one. My first idea was, let me send an email to this person, ask him to go to a given form, leave the username, and I will do the rest. Okay, I will add it to the GitHub API. So I have to solve this black box. And at the time I was learning about Kafka, so why not? Why not trying to practice while I'm learning? And it looked like that Kafka would be a good choice because I could spot that I have some events here. The logic of events will be here. I have patrons being activated, patrons canceling, all those things. But also, this made sense in the perspective that my architecture will keep growing with new services. So this was my starting point. And I faced a challenge right away. I went to patreon.com, looked for the API documentation, and it's a fantastic API documentation if you like to be fooled. Okay? If you don't like to suffer, don't use it, to be honest. But at least they have a good thing. They have webhooks, okay? And with a webhook, it means that they can call an HTTP endpoint on my hand, and then I can do whatever I want. So this is my starting point. So what I decided to do was something like this. Patreon will call a given HTTP endpoint on my hand, and what I have here is an HTTP trigger Azure function. Okay, I'm using serverless because I don't have that much load. Okay, and that way it can be free. So I start that way, and then I will send that information right away to somewhere. And since I was studying Kafka, why not? So the first question that I had to answer was, okay, it's Kafka, but where? Okay. How do I install Kafka? You can do it with Docker. You can install it in your AWS account, Azure, whatever. I decided to use something that is called Confluent. Okay, let me just log in because they are always logging off. And Confluent Cloud is basically a platform as a service offered for Kafka. By the way, while learning Kafka, you can see that it's really expensive to handle this thing. Uh, by the way, when learning Kafka, you will see the word confluent a lot, really a lot. Why? There's a historical reason for that. Kafka was first created at LinkedIn, and then some years later, some elements of that team went to co-found this organization, the Confluent. And the goal of Confluent is to be basically the main steward of Kafka, is the way that I see them. But they invest a lot in the community, so you see a lot of talks from people from Confluent, you see a lot of libraries from them, you see a lot of things with the name Confluent attached. I don't work and I'm not affiliated to them, but I use the product mainly because I don't have free time enough to record videos. What about patching my Kafka version, right? So I decided to go with this software. And here you can see what I have. I have a cluster. So our first concept of Kafka. They install it on Azure, but that in fact doesn't matter. I will open it and we'll get back here in a moment. You know the word cluster, right? You have seen it on SQL Server, things like that. But even on SQL Server, you don't write to the cluster, right? You write to a table that is inside somewhere in that cluster. What is the parallel on Kafka? The equivalent concept is something that we call a topic, okay? A topic, the way that I like to put it is a kind of a log file, okay? Where each line is a message, okay? You can think about it that way. And what basically the term that we usually use is a commit log. And then you will see that Kafka has some particular things that are really special. For example, if you want to add a message to Kafka, you always add it to the end, okay? You can't do other thing with it. Even if you have a mistake, for example, on this one, you can fix it, okay? The only chance that you have is to append something to the end to fix it. The same way as an account balance. If you need to correct the balance because of a previous movement, you need to generate a new movement. Why? Topics are immutable, okay? The other thing that is special about Kafka is regarding those numbers that you can see here, okay? Topics are in order. You can see the messages from start to finish in the correct order, okay? And that is extremely important, as we will see in a few minutes. Also, they have a number, right? And to that number, we call the offset, okay? The number is the offset. Keep that in mind. So if we go into Confluent, and let me just zoom out, we have here our topics. So my first thing was, let me create my topic. And when you create a topic, you have to provide a name. And also, is asking me for something named partitions. What is a partition? Basically, I lied to you, okay? A topic is not like a simple log file. It's a distributed log file. We call it a distributed commit log. Why? Because to have a complete topic, you need to join all the partitions. The partitions is the way that Kafka will spread information across multiple brokers. What are brokers? Basically nodes in a server, in a cluster, okay? Nodes or servers, you can think about them that way. This is really important because it's this way that Kafka can be extremely scalable. It's because of this that so many huge organizations like PayPal, Netflix, and LinkedIn, it's because of that they use Kafka. Because you can keep adding brokers to your cluster and adding partitions, and you scale that way. So a partition is a portion of a topic. That means that when you send a message to Kafka, what will happen is that the message will land, for example, in partition number 2. Okay? Now that you have the message on partition number 2, likely will ask me, but what if the broker 2 dies? Okay? You have a problem with it, and now do you lose your messages? No. Basically, if that happens, let's say that this one goes away, you still have those things that you can see here. So partition number 2 and partition number 2 in orange, that we call them replicas, okay? Partitions have replicas. And to the ones in orange, we call them followers. to the ones in blue, we call them leaders. So when you are talking with Kafka, you will connect to the leaders, you read and you write data into leaders, and eventually your replicas will be refreshed with most recent data, and that way you might not lose data, but we'll talk about that later. What will happen once you lose broker 2 is that Kafka will start a process that we call the leader election. And based on that leader election, you will decide which broker should now be the leader, okay? Is this partition here or this partition here in best position to now become the leader? So which one is more accurate compared to what you are expecting? So now we know what is a topic, now we know what is a partition, a cluster, right? So I'm ready to start implementing my thing. So I told you that I have an Azure function here that acts with an HTTP trigger that will be sending data into that thing on the right, okay? But how do I do it? So this thing is implemented with .NET and C#, and the typical way of doing it with C#, when you search in Google, you will be redirected to this thing. Confluent, once again, Kafka.net, that is a Confluent client, a small library to connect to Kafka. Okay? This is the typical way. However, this is not the way that I do. And I will show you the one that I use. There's nothing wrong about this library. Okay? It's perfectly fine. However, it's low level for me. Okay? When you are building an event-driven architecture, everything is fine? Yeah. When you are building an event-driven architecture, you will notice that most of your applications will keep using the same stuff, will keep doing exactly the same things. For example, you might have things to process data in batches, and you need to implement that over and over again. So I would like to use this another one that is also open source, that is Kafka Flow. And Kafka Flow is a framework built on top of that one that I just showed you, so you can still fall back into the other one. And Kafka Flow has a lot of advantages, at least to me. You will notice during my presentation that you'll be using a fluent way of describing your services, what is good. And also, you will see some features that make it special, that are things that if you need to implement by yourself, it is a lot of work. And we'll realize that once you apply to one, in a huge network of applications, you will see a lot of them needing the same thing. So it's a way of simplifying your work. But everything that I will show you, you can do it either way. You just need a bit of extra of code if you use this one. So, keeping on. How do I do it with, can you read it right on the back? Yes? Okay, sorry, I didn't have the time to test if we could read it well back then. But can you read it? Yeah? Anyone? Yeah, perfect. So, what I've done to use this thing, Kafka Flow, I installed a NuGet package, as always, and now what we will need to do is to go to your dependency injection configuration. It can be on your startup, program CS, or for example, in this case, I decided to extract an extension method, okay? And in this extension method, what I'm doing is just calling that method, add Kafka. That is a method by Kafka Flow. And then I will define, okay, which login provider do I want? So basically, if I want to use the iLogger of Microsoft, if I want to use Cellulog, those type of things. And then I will say, how do I connect to my cluster? Kind of the connection string to Kafka, okay? So I will use the data that Confluent Cloud gave me, and I will connect that way. Then we have here another concept that I need to explain as well. While you might be familiar with something like publish subscribe, right? PubSub. So when you send data to somewhere, you are a publisher. When you read, you are a subscriber. In Kafka, they have different names. So when you are sending data to a topic, you are producing data. So you are a producer. When you are consuming data, you are a consumer. So keep that in mind. And that is a kind of a role that an application will have when connecting to your topic. So in this case, what I have done is say, okay, this application is a producer. And that producer has this name that I will use in a moment. And also, please, by default, write to this topic. If I want to write to a different place, I will let you know. And then, since I don't have a lot of money, please apply compression, okay? By default, Kafka doesn't apply compression to messages. However, if you apply compression, you are saving in network and also in storage, okay? There's multiple types of compression types. Gzip, I need to see them. I always forget. But okay, there's 4 or 5. But when you use compression type, you are basically doing a trade-off between the CPU time that will take to compress that thing, okay, in read and write time. So you need to take those decisions. Kafka is mostly about trade-offs, okay? It's mostly about that. Gzip does an excellent job to compress things, but you always need to think about those things. As you have seen, with just those few lines of code, I have defined my relationship of my Azure function with Kafka, okay? So now the only thing that I need to do is wherever I want to produce that message, to send that message, I just need to call a simple method. And I have that here. So you will notice here that I'm getting through dependency injection, something that Kafka will give me, Kafka flow. And then I'm getting from there the producer with the name that I just configured. Then the only thing that I will need to do is right here is, okay, please produce this message that is right here. Now you might ask, what is a message, right? And that is a good question, because I didn't explain that yet. If we go into, I will use now another application, but you can see this as well on Confluent Cloud. However, if you are into Kafka, take a look into Conductor with a K, and it's as an amazing experience to the developers. And let me open here one topic. This that I'm opening now is a topic. Loading, 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 time for water. Okay, and here you can see 3 messages. And messages have just a few types of things inside. Let's start by the value. This thing that you can see right here as a JSON, okay? Don't think that it needs to be a JSON. It doesn't, okay? Kafka wants bytes, okay? Kafka doesn't want JSONs, doesn't want protobuf, doesn't want any of those things. And that is also the beauty of Kafka, because now you can bring Kafka to support an event-driven architecture, and everyone is producing events and things like that. Then your data team wants to bring some technology to ingest that data into somewhere, and they are not locked in to a given protocol. Okay? Kafka can grow with your business because of this type of things. So is also part of the beauty of it. In this case, it's JSON because it was the way that I serialized the data. Okay? It could be another thing. The other thing that a message has is a key value pair with headers. Okay? Kind of like HTTP request. You have the headers. You can use them to simple things like correlation IDs, message types, things like that. There's metadata where you can see that offset that I told you, it's here. So this is the message with offset number 8, okay? But there's other information like the partition where it is currently, dates and things like that. But the most important one that I want to pay attention when you are designing your system with Kafka is the key. The key is really important to take a good decision when you start with this thing. Let me show you the source code again. Did you notice here that I'm in message key, I'm sending the email, or a default text that is unknown? And why I'm doing that? Because basically, I'm using the unknown because I don't trust their payload. The documentation was lying to me, so I will just have this as a kind of fallback. But I'm using the email for a simple reason. Imagine that I get an event from patron saying, okay, this patron has paid successfully his membership, Okay, so for me, now this person is active. Then, a few moments later, I get another one saying the membership was canceled. Now imagine that I process them in the other way around. Okay? The output of the system is different. And I told you that in a topic, messages are in order, right? However, when you are consuming them, you can only consume them in order if by partition. So you need to ensure that every single message that for a given context that needs to be processed in order, that lands exactly in the same partition. That is really important. So imagine the following scenario. I'm sending a message. Well, the first message that I told you, that goes here, and the other one goes here. Now, who's reading this thing, since this thing is scaling through multiple servers, I can process them in different orders. When I set the email, Kafka will use a thing that we call the distribution strategy. Yeah, this strategy that they call it. And the distribution strategy will basically apply an hash on top of the email. And based on that hash, we'll calculate that, okay, this one should go here. Okay? So every single time that I send exactly the same message key, it will go always into the same partition. It's a way of making sure that that happens. Now you might ask, what if I don't care about that? The only thing that I want is to produce messages. Okay? I don't care about the order. Just set the partition, the message key to null. And on that case, what Kafka will do is to apply a round-robin strategy. So it's the most efficient way for throughput of your system. Okay? First goes to the first partition, then to the second, then to the third, then gets back to the beginning. Always like that. So defining the correct message key is really important. It's important to think about that when you are building your first system. Okay, so now in our application, I'm getting an event from Patron, I'm processing with an HTTP trigger, and I'm sending the message to Kafka. Perfect. Now I need to handle that message. I need to transform it into something that has a meaning to me. Because as you can see here, what I'm getting is a huge payload with a lot of information that doesn't say anything to me. And the message type that I get from them is like new member, member updated, member deleted. Okay, just that. And the member updated might be a lot of things. Might be that it was paid successfully, the card was invalid, or the person decided to cancel the membership. A lot of things. So I need to convert all that information into something that has meaning to me. So what I decided to do was to bring another application. Okay. By the way, this is not a talk on how to avoid over-engineering. Okay. So what I've done is that I created that patron manager that has an internal state, and based on the inputs, you will calculate what changed. And based on what changed, I know is a new patron that I need to give access, that I need to send the email, or is someone that I need to revoke the access. And when I know that, I will publish into another topic that is specific for this type of domain events. The one on the right, we'll talk about that later. One thing that you'll notice here is that for the first time, we have a consumer. A consumer is something that reads data, remember that. But you also notice that this application plays multiple roles. Okay? He is not only a consumer, he is also a producer. So an application can have multiple producers or multiple consumers. So don't think about Kafka as only a technology to connect tiny, mini microservices as you see on Netflix, okay? So it's not about that. An application can play multiple roles. And since in this case, the domain is that, it made a lot of sense to me. And what does this application has of special, okay? Let's take a look into the source code. Move into the Patron manager that is right here. Okay, and now what you should notice here is that besides the add cluster thing that I showed you, okay, we have seen this already. I also have the add consumer. So it's not a producer, it's a consumer. And when I have a consumer, I need to say a few things. For example, I need to say which topic I'm consuming, okay? where I will be looking at to get new messages. I give it a name. This is useful for operations, if you want to see in some dashboards and things like that. This group ID, let's leave it for a while. We'll get back to it. This workers and buffer thing is one of my favorite features of Kafka Flow. Why? Because I told you that Kafka is highly scalable, right? You can bring more brokers and partitions, so you have more consumers reading them. But often you will notice that you will have a single application that is handling message after message, but your topic, the leg of the topic, the number of messages to process keeps growing. And you see that the resources of that application are not being used, like memory or CPU. So you want to take advantage of those. With workers, basically Kafka Flow does multi-threading for you, but does it in a way that preserves the order of the messages, what is really challenging, but extremely useful. So it's one of those small details with a single line that you have for free with Kafka Flow. Also, I'm saying here, please read everything from the beginning. I told you that messages are in order in a topic, right? That means that if you go to the beginning of the topic, you can start rebuilding a complete data store for your application. Because one important thing about Kafka is that on that topic, when I read the message, I'm not working like a queue. In the queue, when you read, you get the message out. So the message is gone, no one can read it again. While in Kafka, those two things are decoupled. The process of reading and the process of deleting are two different things. Messages might be deleted one day, but they might be, okay? We'll talk about that later. But that is one of those small details that make Kafka extremely efficient. You know that the cheapest thing to do with I/O is to always write things to the disk instead of deleting or changing them. Okay, so I'm saying please read it from the beginning. So what happened in my application is that the first time that I started this thing, that I deployed it, it went to the first message coming from Patreon that I already had on my topic, rebuild everything. If now I need to delete the store that I'm using, I just need to start it again, with reset the offset to the beginning, and it will replay every single thing. It's a valuable thing to do. And also, you will see that Kafka Flow has here an option that is called middlewares. If anyone here has ever used something like Mediator, you are familiar with this concept, the concept of a pipeline, of a chain of responsibility. Basically, Kafka Flow gives you a way to create a pipeline where a message goes into the first middleware. That middleware can handle it, can transform it, can do whatever you want, and then deliver it to the next one, okay? And so on and so forth, as you wish, okay? It's like Lego blocks that you will piece them in the way that you want. And what I'm doing here is as simple as saying, okay, the message is coming out of the topic, and as I told you, Kafka only works with bytes. So I need to transform that into the typed system. So I will need to deserialize that thing. So I'm using a serializer, using Newtonsoft. There's a lot of them available right there, like Protobuf and MessagePack and others. They are right there by default. And once the serializer runs, by the end I will have a message type, okay? An object that represents that message. So I will deliver that message to a typed handler, and that typed handler will do a simple thing like you know on Mediator. Okay, this message is, for example, a patron updated event, so please handle it, dear class patron updated event handler, okay? As simple as that. So now the only thing that you need to do is to go to that source code and implement the logic. So one of the beauty of this is that through the configuration of your system, you describe the complete relationship with Kafka. Then I just need to focus on writing my code, the code that will send email, the code that will do whatever I want, okay? And this is usually the hardest part when working with low-level libraries. The other thing that I told you is that this application is not only a consumer, as we see here, it has another roles, like another consumer, or for example, a producer. And this producer has one different thing from the other ones. That is this with X. That is extremely important in Kafka. If we go here and we click, we'll see that we can do it as a none, leader, or all. What is this thing? X, you can consider them acknowledgements. And let me go into the partitions diagram. That will help. I see Kafka as an hybrid between a database and a messaging system. And you have all the options to configure if you want it to be more one of them or the other one. There's a lot of trade-offs on your decisions. And one of the decisions is this acknowledgement thing. Why? When you send a message, it goes here, okay? And if I set the acknowledgements to none, what will happen is that I know that I send the message, okay? And I will get a response. But the response will say successful even if the message is not yet stored on that partition. Okay, so I might lose data. It might sound strange, but if you are building, for example, a system that is based on telemetry to monitor some things, you might consider to lose some data, and the trade-off is performance. So this is the most efficient way, the fastest way to write data into Kafka, okay, with a none. However, let's say that I don't want that, and I want at least to make sure that the data is already in the partition. So the data will go into the leader, partition 1, and then once get back, I will be able to see if it was committed into the partition successfully or not. What if it is there, but I lose that broker and the replicas are not in sync? I lose data once again. But I don't want to lose those account movements, things like that. So I can set the acknowledgements to all. And by doing that, what will happen? Go to the leader. Those ones need to be in sync. And only then I get the answer back saying, we have it. Okay, we will not lose it. Okay. So obviously this last one will take more time. And if you need that huge speed, you know that you have a trade-off to make here. So this is why I say that it's kind of an hybrid between multiple things, multiple decisions that you will take. Another thing that I wanted to share with you is that with Kafka, you can do batch processing, okay? You can produce things in batch and read them in batch. And you can do a batch with multiple topics. That is another trade-off that you can have if you want to latency, if you want the throughput of your system, if the time that takes to process a single message is important to you, you can decide to use batch or not, all of those things. Okay, getting back into our diagram. So now what is happening here is that someone is a new patron, call it the HTTP endpoint, I store that in a given place. By the way, this is an excellent strategy if you don't trust third parties, because if something goes wrong on that API, if they refresh it, if they do a mistake, I already have the events here on my hand, okay? So if something goes wrong when I'm ingesting them on my patron manager, I can handle it later, okay? It's on my control, and I don't trust them, so it's what I'm doing. So now I'm producing events into this one saying, okay, I have a new patron and it has been activated. So let's handle that thing. I told you that my goal is to send an email, right? Simple, just create another consumer. Now you know how to do it. That consumer will consume that topic, and then I will react to it to send an email using SMTP. I'm using SendGrid. You can do whatever you want. However, there's a really important detail here. First time that I deployed this thing into production, what happened is that a friend that was a patron told me that he was getting duplicated emails from me, okay? So I had to take a look on that. And I realized that it's because Kafka has the concept of deliver at least once. So Kafka will make sure that you get the message, but it doesn't promise you that you only have one, okay? So we will try to send it back if he's not sure. So what do you need on this case? You need idempotency in your system. Is another concept that is really important to think about on this type of system, okay? Have some way to deduplicate messages, okay? Sometimes it can be easy, like in this case, like a simple table saying, have I already sent the email to this person or not? Okay. Other times it might be a bit harder to do, but always think about that, how you will duplicate those messages. It's highly important. So I'm sending those emails. Those emails contain a link. The link will redirect them to another application that is a web application that has a form. On that form, you have a field to set your GitHub username. First implementation that I've done, let me call the GitHub API. However, it was not a good idea. Why not? Not sure if you know, but the GitHub API has throttling, and you can do only a small set of requests per hour, okay? Not that I have that many, a huge number of patrons. However, when you are testing and things like that, you will notice that. The other thing is that the API might be down. Or worse, that happened to me, I forgot to refresh my access token. So someone went there, typed the GitHub username, clicked, error. Try again, click, error. Don't try again, okay? So I lose a patron by that. So what I decided to do is to instead, okay, I'm using Kafka. Why I don't write it to a different topic? And I can handle it later. If the GitHub API is down, no problem. I can run my consumer later. And this is another cool thing, because now I can scale and I can have a different throughput either on my producers or on my consumers. I can take those decisions. So what I've built is another consumer. You can see it's always the same pattern, producers and consumers. And by the way, this application has a producer to write into here. And on this one, what I'm doing is that, okay, let me call the GitHub API, perfect. But you will notice that I have 2 arrows getting out of that topic. How's that possible? This is another thing that everyone values on Kafka. While in the message queue, the message is processed by someone and no one else will look at it, right? In Kafka, you can consume the same message with multiple intents. For example, the intent of this application, this one, the GitHub Patron Manager, okay, is to call the GitHub API to give access. However, I have this other application that maintains an internal stage, internal picture of my patrons. Why? If I need to recover something, if I need to do something manually, I can always do it. So I need to read exactly the same message twice, one for one application and the other one to the other one. And how do we do that? You might remember that here, when I was talking about the consumers, I skipped this group ID. This is the concept of consumer groups. The consumer group, it's like a role that an application is playing inside of your system. So you can have multiple instances of consumers, so multiple consumers, but they all play a single role. The way that I like to explain this is with the example of a book, okay? Imagine that I'm reading this book. And imagine that this book is a topic, okay? Each page on the book is a message, okay? The number of the page is the offset, okay? So now, when I'm reading, okay, let's say that I bookmark on page 50, let's say, keep the bookmark there. I know that last message that I've read was the page 50. So I can leave the book, go do other stuff, get back in the month, and I know where I left off. It's exactly the same concept as Kafka. So when I finish to read the given message, I can commit my offset, last one that I just read. And I told you that this one of the dark side is mine, so I'm reading this thing. That doesn't mean that someone else in my home can pick the same book and read it as well. For example, let's say that this another one is the bookmark of the bedtime story of my daughter, because she falls asleep when I talk about test-driven development. And since it's the bedtime story, it's for her, for the purpose of she falling asleep, okay? But doesn't mean that she needs to read it. I can grab the book, and I know that we left on page 90, something like that. I read a few pages this night, okay? And then I commit it again, right? I have the bookmark there. I leave the book. Next day, my wife will come, she will open the book, she will see, okay, so they left on this page. She doesn't need to know the previous pages, the story behind. She just needs to read the following ones, the following messages, commit it again, leave the book. We are both working on a consumer group. It's basically that, okay? And the beauty of it is that I don't need to carry a post-it note with me saying, I left this on page 100 yesterday, right? That information is inside of the book, is inside of the topic. With Kafka, we store that without doing any effort, by the way, in something that is called Zookeeper, or nowadays there's a way of doing it inside of a topic itself. And the same thing is happening here. I have two applications working with two different consumer groups. So they will consume the same message. You can even see that on your applications that connect to Kafka when you are managing that. Or for example, this one is dev, so let me go to prod. And if we go here into consumer groups, you will see that I have two applications that play two different roles connected to the same exactly topic. Okay, so we'll process the same messages. You will also see an overall lag. What is this? Kafka will tell me how many messages each consumer still needs to process. So currently they are all in the last message, so they don't have anything to do. But if I produce now a lot of messages, they might go in different speeds. So one in a few minutes might have a lag of 50, and the other one might be in 0 once again. Same thing with books, okay? I still have 100 pages to read. It's my offset lag, basically that. This means that if in my architecture, I need to bring now something like a mailing list, okay? Let's say that I want a new mailing list. And what I will do is, okay, let's say that this represents my mailing list. To me, it will be as simple as having another application here that is consuming exactly the same events and calling that. To this, we tend to call an evolutionary architecture. I don't need to touch the existing pieces, right? I just keep adding features. And obviously, this will sound ridiculous to you because we are talking about a single guy with 5K subscribers and 10 patrons or something like that. So over-engineering. However, imagine this in a news organization where someone is producing to a topic the data of your clients, and marketing wants it, logistics wants it, everyone wants it, and everyone needs to read exactly the same things. And they don't want to be waiting for each other, okay? So that's the goal. Last thing that I want to show you. Remember that I told you about this thing, that we'll talk about that later? This thing is a snapshot. So every single time that I send a message with the domain event to the other side, I also want to send here a picture of the current state of that patron. Why? Imagine that I want to export something like a CSV file, or I want to create an application to run something like a raffle to give some prizes, things like that. And I want to connect to something that looks like a table, okay? Make sense? Another example that you can think about is, imagine that in your company, there's a service that is responsible by customers or clients' addresses, okay? So to the rest of the organization, previous versions of the addresses of those clients doesn't matter. What it matters is the last one, and you want that picture. So how do we do that? Let me go back here, and remember that I told you that the process of reading and deleting data was decoupled. They were two different things. That happens because when you are creating a topic, let me just zoom in for your benefit. You will not only need to say the topic and the partition, but you can also define a cleanup policy. By default, Kafka will do a strategy of deleting all data when some conditions are met, for example, time or the size of the topic. And Kafka wants to do this to keep optimizing itself, okay? Ideally, you have this. However, if you need it, play carefully, you can do this. Okay, it can be there forever. Okay, up to you. However, this might be, for example, extremely useful if you have something like this message as PII, protected identifiable information, something like that, personal identifiable information, and due to GDPR, you want to delete that data after 1 year. Okay, Kafka can do it for you, for example. However, there's something here that is strange to me, but I'm using on that topic itself, that is the strategy of compact. Compact doesn't look a natural thing to me, to be honest, but makes a lot of sense. I told you that the message key plays an important role in Kafka. It's not only because you need to make sure that messages are processed in order in a given place, it is also when you need to do this compact thing. The compact is useful for cases like this, where only the last picture, only the last message matters from now on, okay? The oldest versions of that address, the oldest versions of that patron doesn't matter. It will basically do a kind of a distinct inside of your topic. Does that mean that you always have a single message per message key inside of a topic? No, it doesn't mean that. It means that when it runs, it will optimize by deleting the oldest versions of that message key. So if anyone now goes and points the application to the first message and reprocess everything, you will capture only one version of that message, okay? But you are not assured that that will happen. So during this hour, I have told you about the challenges that you face when you are building this type of applications. I told you the basic concepts of what is a topic, what is a partition, what you need to think about, what is a producer, what is a consumer. There's other things more in Kafka. There's things like streams, there's things like Kafka Connect, there's things like a schema registry, okay? But honestly, everything that you have seen today is what you need to do your first diligence to understand if Kafka is useful for you. To go to a job interview and someone asks you something about Kafka, and at least you have some ideas of how that is useful. Okay? It's enough to have the basic knowledge of what Kafka is, because even things like streams are built on top of these concepts. Okay? So I hope that you learned something today, and I hope that you enjoyed this session. By the way, the first one coming to ask a question will take a prize from Portugal. Okay? And thank you. Obrigado.